All right, here's 8.1. We're going to introduce the idea of a confidence interval. And in the first section, I'll give you a little example to kind of go along with some of the basics. But as far as like the details of how confidence intervals are built, I'm not going to really dive into that until section 2 and 3. We'll kind of have the same setup as chapter 7, that first section is the basics. Second section will dive into proportions, and then the third will dive into means. Okay. Now, just to give you an example to kind of go along with some of these ideas, I'm gonna kind of lead into section 2 and give you a proportion. Because basically what happens now in chapter 8 is we get a little more realistic. We can still obtain a statistic from a sample. If it's a proportion, we call that p hat. If it's a mean, we call that x bar. But now we're going to say that we'll call that a point estimate as well, just to contrast it from an interval. So we have our statistic. We have it's kind of our best guess as far as the parameter. But here's really what's going to change. All the time in chapter 7, we were given, whether it was like a mean or a proportion or a standard deviation, we were told what the parameter was, which was helpful because we were getting into the difference between parameters and statistics. That's not going to be the case anymore because it's not realistic. The whole reason for getting the statistic is that you don't know the parameter. Okay? So here's the bank example I'm going to give you. This bank is interested as to what proportion of customers that call in, it takes them over 30 seconds to talk to an actual person, if that's what they're seeking to do. They took a random sample of 241 callers, and they found that 201 of those 241 had gotten through to a person in under 30 seconds. That's 0.834. That is a statistic. Okay? Now, to go along with this, we don't know the parameter. That would be like the actual proportion of customers. If every single customer this bank has was sampled, like how long are they waiting to, or what proportion are waiting over 30 seconds? Actually under, because what they measured was who got through under. Okay, they wanted it to be 100%. They found from their sample it's 83. I have a statistic from a sample of 241. I don't know the parameter. Okay, I really don't. But I can build an interval that'll give me a certain level of confidence as to whether or not that parameter is in my interval. Okay, so here, that's p hat. I'm going to look ahead a little bit. This is how the intervals are constructed. That 2, we'll talk about that. That is called a critical value, and it comes from how much confidence you want to have in your interval. That formula should look familiar. It's called standard error. Okay, and we go that far on either side of our point estimate to build what we call a confidence interval. Okay. Here's some of the big ideas. Centered at the point estimate. Again, that would be p hat or x bar, depending if it's a mean or proportion. So, margin of error, that's how far on either side you're going to go away from your point estimate. And your margin of error, I already pointed this out, has 2 parts to it. You have your critical value and standard error. Okay. The whole thing together is the interval, right? How far on either side is the margin of error? Confidence level we'll talk about more, especially in class. There you have to think if you were to construct repeated intervals, okay? But we'll get to that in a bit. Here you really don't need the part up top. It's saying the same thing, but focus down. Just focus down here. So this is really in your 4-step, what you would say for the conclusion, particularly right here. You're going to see that for the conclude step. So the confidence level, okay, is saying that if you, it kind of goes along with chapter 7, that if you did repeated samples and you constructed lots of intervals, okay, some of them would capture your parameter, some of them won't, okay. How wide you make it determines how confident you are that the parameter is actually going to be in there, okay. So if we set, you'll see 95% is a really, really common confidence level. What that means is if we did tons and tons of intervals, and we made them all the same way, from the same sample size, and we did it again and again and again, okay, think repeated samples just like chapter 7. 95% of the intervals that we construct would have the parameter. 5% would miss it. Okay, that's what confidence, that's what tells us kind of how sure we are that the parameter is in there. Your interval, again, that comes in your conclusion. There we would say that if our confidence level is 95%, or 95% that our interval, and then we'd cite the endpoints of the one that we made, captures our parameter, but we would just state it in context. Okay, so the difference between confidence interval and level is important. All right, so here's a few more details. I'd already talked about this, right? Critical value and standard deviation of the statistic. I've called that standard error. You'll see the book and homework assignments use both terms, okay? Together they form margin of error, okay? And on the last couple slides here, I'll go back to our bank problem, and we'll actually construct the interval, okay? We choose the confidence level. Okay, we have tons of different options, but we typically will choose 90, 95, or 99. The one thing you should understand is if you bump your confidence level up, your interval gets wider because you're saying with more certainty that you feel the parameter is in your interval. Okay, you could say that if your interval is wider. If your interval is really narrow, right, you can see down at the bottom it's got this little diagram of the top one. That's just 80% confidence. You bump it up to 95, you got to build a wider interval. Okay? So two things that you can do if you want to reduce your margin of error. You can decrease your confidence level. That'll make your interval more narrow. The other thing you can do is you can take a bigger sample size, right? Samples vary, but we also know that bigger samples are more accurate. Okay? All right, before we would actually construct the interval, we would technically check technically 3. You'll see in a 4-step, you should only write about 2. And they shouldn't look brand new because I've been kind of pushing this 4-step at you for a little bit now, especially in chapter 7. One of them is random. And if I were to go back to my bank problem, I would say we have SRS of n equals 241. You could say callers, customers, doesn't matter. Be sure to have some context with it. I'm going customers. I switched it. Okay. The big thing there is this is how we fight bias, right? We have to make sure that our sample was selected randomly. If it wasn't, don't trust your interval at all. I mean, all this stuff wouldn't say anything about how confident we are that the parameter is in there. Two is normal. Okay, this is a proportion, the one I've been doing. I said 201 people got through in under 30 seconds. 40 didn't. Both of those numbers are at least 10. Okay, now the example I've been doing is a proportion. You can see there it has the criteria for proportions and means. They should remind you of what you saw in Chapter 7. They're exactly the same. Okay. Means, you would be looking to see if the population is normal, and if it's not, you needed to select a sample that's at least 30. So there is a third condition. It's where the 10% condition shows up. I'll address it. Okay. We would say the bank $2,410 customers. Okay, that's where the 10% condition shows up. So it's like if we were sampling without replacement. If we're under 10%, it doesn't matter. We don't have to be worried about that element of independence. Let's put right with that. Don't need in a 4-step. Okay. If you use your book for any examples, you will see they address all 3 conditions. You don't. You just have to do the first 2. Okay. So let's head back to our data to get our interval. Here's our statistic. Right, that came from 201 over 41, plus or minus 2. This is going to be a little bit of a mystery for you, and it's not actually totally true. But I think I can put the pieces together. I'm using a 95% confidence level. Where the 2 is coming from is, remember that back on a normal curve, way back when we first saw it, we had said that about 95% of outcomes in a normal curve happen 2 standard deviations away from the mean. I should say within 2 standard deviations of the mean. That's actually what's going on here. Is I'm saying my distribution is centered at 0.834. We're going to go 2 standard deviations away. 1 standard deviation is this. That would be your standard error, and it's 0.02396. Okay? So here's what's going on. We take our sample of 241, and we get 0.834. that number I just calculated tells us that if we did repeated samples of 241, on average they would vary by about 0.02396. In other words, we got a sample of about 83% of callers are getting through in under 30 seconds, but in repeated samples, that would vary by almost 2.4%. Okay? Think of that like one standard deviation on our normal curve. We are going to go 2 standard deviations away. By the way, this, if I did 2 times 0.02396, I would get 0.047935. If we go back to the definitions we wrote down earlier, that number is called your margin of error. Okay? It's how far on both sides of 0.834 I'm going to go. I'm going to subtract that number, and that'll take me down to 0.786. And then I'm going to add it, and I'm going to go up to 0.8819. And we have ourselves a confidence interval. Okay? This is telling me that based on the way I constructed it, we are 95% confident that that interval, 0.78 to 0.88, captures the true proportion of callers that are getting through to a person in under 30 seconds. Okay? So again, notice the difference. We got a statistic, just like Chapter 7. We don't know what the parameter is, the actual proportion of callers getting through in under 30. We don't know. We're 95% confident it's somewhere between 78 and 88%. Okay? We just took a sample of 241 and got an estimate that would vary a little bit, but even within that variability, we're pretty sure our parameter is in there.